Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're gonna talk about a viewer requested topic, Soyuz rocket. So let's dive right into it. Well, first we have to understand what the heck we are talking about. We are talking about an orbital launch platform. So it's not a ballistic rocket, it's a basically a launch platform. It's almost in the same category as Falcon 9 and all other jazz. So it was made in USSR, aka it's very old. And right now it's basically creation and maintenance and all that goes under the jurisdiction of Russia. Now the first time it was launched, it was in 28 November 1966. Yes, this is 1960s technology, and it has two primary payloads. Either it's gonna carry a Soyuz basically progress craft. Progress craft is just a cargo variant, or Soyuz manned craft. Basically, this was the reason why it was built, and this was the foundation of Mir system. However, it can also do satellite launches because if there is another satellite launch provider compared to basically USA, it's Russia, and because of this exact rocket, it's quite reliable, it's quite efficient, quite cheap also. So it's a very capable rocket from 1960s. So how the heck this works? Well, you have to understand this. Soviet Union was quite ahead in terms of rocket technology, and they were making YOLO amounts of ICBMs. However, in as early as 1960s, they realized they can make their ICBM weight much lighter while increasing the yield. So basically, their machine shrunk. Now, what does that mean? That simply means these rockets became way too overpowering. So instead of making them smaller and basically just an ICBM, they decided, okay, let's create a new system for ICBM department and use this rocket as a space vehicle. So because putting something in orbit compared to throwing something using ballistic jet, they are different requirements. So going bigger in terms of orbital mechanics helps you out. So they've made multiple variants of it, and that's why you will hear people say R7 family. That is the whole point, because it's in a family. The whole architecture was taken as a wholesale, then refined over time. So it would be equivalent of saying Falcon 9 and Falcon Heavy are from Falcon family. That's the reason. So this uses rocket propellant 1, aka kerosene, aka ultra refined kerosene, plus liquid oxygen. So basically it's almost the same running fuel as Saturn V's stage 1, and it has three primary stages. However, it is kind of very unique in this regard simply because it has multiple types of staging. Now space shuttle used to do what we call parallel staging. So engine will run and your parts will go sideways, and then the second step will happen. Or in case of space shuttle, nothing, there was no second stage. In this there is parallel staging, so your engines will keep working and while you are still jettisoning part, plus there is also serial staging. So it's kind of unique in this regard. So it used RD-107 rocket engine. Now what's unique about this rocket engine is because it has variable mixture ratio. What does that mean? That simply means they can fine tune how much liquid oxygen goes and how much liquid kerosene goes. Is there a benefit to that? Absolutely. You have to understand that this whole system has 4 nozzles and there are multiple clusters of this. So basically one engine is in the center, 4 are in the boosters. So you are talking about 5 systems. Now, if 5 systems, that means 5 fuel tanks that are depleting. If they end up in a scenario where they are not depleting properly, as in like all the levels are going down like this, they could generate a scenario where they are creating torque. So basically they can twist the rocket, and to compensate for that, computer have to overwork, or the rocket engine have to do something that it cannot do, which will result in a boom outcome. So to make sure there is no boom outcome, it was a kind of necessary. It was not done out of okay, we can do that. It was like we have to do this in order to make sure our rockets are reliable. So for its time, it was quite amazing that they figured it out how to have independent liquid oxygen and liquid kerosene control. Now when I say this is old, this is what I mean. This is old because right now, if you go into any rocket engine made in any modern time, the logic right now would be you take a little bit of propellant, you take a little bit of oxygen, and you burn them. Generally, unbalanced ratio where you will have either too much fuel or too much basically oxygen, so you do not get very hot exhaust, and then you use that to power a turbine. That turbine will power the pumps. Everything is simple. You do not have to carry something else. Now, this system is a direct descendant of basically V2 rocket. What does that mean? That simply means this puppy is having a own independent gas generator system. So it had basically what we call gaseous oxygen water vapor coming from a peroxide mixture. That peroxide was decomposed over catalyst, and that exhaust from that peroxide was used to drive the turbine. So it had it's completely different. So it not only had like 2 primary tanks, it had a third tank which was just to power the whole system. So it's completely different. It's a completely different thinking mindset than we use compared to Falcon 9 on space shuttle, or even Saturn 5. It was completely, Saturn 5 used kerosene itself to create the gas exhaust. This had an independent system. and it had 4 combustion chambers. That's the working of it. That's why it's so unique. Now, Korolev cross, yeah, I'm sorry about the pronunciation. I'm really sorry about that. Can't pronounce it. But it does make a very unique cross when it, what we call parallel staging. What does that parallel staging mean? That simply means your engine are lit while you are staging. So you have 5 basically clusters. One is your core clusters, and other 4 are secondary clusters. Now, this is so old that gimbaling technology was not reliable enough yet, or even so, nobody could even understood how the heck you're gonna gimbal a rocket engine, why it's working. So they created multiple small rockets, which are called generally linear rockets, and these rockets will provide you basically thrusting. Basically, your engine is fixed, constant, and outer engines are like moving around and doing things. So this did parallel staging. So to make sure that they have enough thrust, enough mileage, they did what basically Falcon Heavy does is all 3 engines are basically cores are lit, they fly, and then 2 side ones are jettisoned, and then the center one goes into full power. It's the exact same thing. Basically, you may even say Falcon Heavy is inspired by this kind of operation. However, Falcon Heavy is much more simpler because it does not have linear thrusters. It just have much higher engine count. So this is the whole point. The 4 cores, basically outer boosters, they burn at full force. Full force. They are like basically providing most of the oomph, so to say. Once they are detached, then the core goes to full power. Now these boosters, when they fall off, they make amazing cross. You watch any video of that, like you don't give a damn what payload they are sending, you don't give a damn whether this is old rocket or not. But when it makes that cross sign, you will be like, yeah, that's on a different level, like truly different level. And that's why this rocket is has cross so tied into its identity. It looks amazing when this happens. Now, what about the history and legacy of it? Well, it has long history, as in really long history. It's like longer than most countries, so to say, latest country, as in. So it's ludicrously long, and it's very successful. It's not just like, okay, somebody made it and they are using it. It's successful. They have had many issues with this. It's not like, okay, perfectly, spotless record, but every accident taught them a lot of lessons and they improved it. And outcome right now, the current variant is very safe, very reliable. So Soyuz 2 had like, if you count from 2006, had 102 launches. That's a lot of launch, like back then, because right now we think about, oh, launch every month. That's only because of SpaceX and only because of Starlink. But before this, like before the SpaceX era, before on basically ULA and space shuttle and all that, was a huge number. The fact that this rocket was successfully doing 100 plus mission, it was on a different level. It had 95 successful missions. That's 93% success ratio. That is awesome for something that is like based on 1970s design. Now you have to understand this. Space shuttle was a rocket. It was kind of successful, but it had a very severe flaw. In any sort of bad event, all the astronauts are done. They're done. Like even basically Saturn V, it was a rocket. They knew it could go boom at any moment in time. There was a way to evacuate basically astronaut. There was no such thing in space shuttle. They inherently thought they could make something like 100% reliability, which physics does not allow. So bad things happen. So what does that mean? That simply means they had 2 accidents and 14 astronauts that lost their life. That is not something that can be tolerated, and for that reason space shuttle project was grounded before any replacement was created. So space shuttle was a failure. Now what happened after that? That simply means USA was left in a position where they had no way of sending people to ISS. Flat out, they were stranded, so to say. So only this rocket was capable of doing that. So for a very brief period of time, this rocket was the only capable mission ready vehicle that can carry astronaut from ground to ISS. And you may say China could do that. Yeah, that is true, but China is not allowed to talk with ISS, so that's an issue. So what does that mean? That inherently means Russia could charge whatever they wanted to charge. And this rocket system is so time tested, they have this as a lifeboat. Literally, it's always docked there. So in case of emergency, if in case, let's say a big space debris starts to hurls towards it and it's going to destroy it, they have to evacuate the astronauts. They can use this as a lifeboats. Like it's that time tested. Now, there was an incident with Soyuz. It's not 100% perfect. It's still 93% success rate. So they had an issue, and quite recently Soyuz MS-10. Now here's the deal. Accidents happen. Rocket is a boomstick, and sometimes it really does go boom. So what happened? Emergency crew evacuation system worked flawlessly. Basically, the system pulled the capsule out and safely landed. It's supposed to do that. So that is why the record of this whole rocket is still clean, because it does not have too many fatalities. So it's quite amazing in terms of history, in terms of legacy, how long it has been working. Nobody is gonna call this rocket amazing rocket, powerful rocket, or technical marvel rocket. Nobody is gonna call that. However, all of them, like you ask any historian that deals with the rocket and all that, it's like this is a workhorse rocket. This is basically, it's an ugly looking truck that keeps working for 60-70 years. That's the whole point of it. This. So what we're going to expect in the future? Well, you have to understand that we want to simplify things. Space shuttle also taught us this lesson. This rocket itself also taught us that reason, simply because even though things you may say it's kind of uses simple things, it uses so many of them, the cost is too high. So we want to go into this, Falcon 9 kind of territory. Falcon 9 literally has lower parts count than this puppy, and somehow Falcon 9 figures out to how to land. So inherently what we want things to be simpler, and like the next variant, basically Starship, would be even simpler than this. It will not even carry a T-tap system. Why? Because it will have electrical ignition system. And right now you have to understand, if Soyuz systems are basically lit by matchstick. There is a giant human-sized matchstick that was put on the basically launch pad. Yes, literally that's how it's triggered. It does work. It's a simple system, but really, like a rocket itself cannot ignite itself. So that's a kind of odd scenario. So we want the simple step. And on top of that, the electronics on the Soyuz system was so ancient, flat out so ancient, that until the recent updates, they had to rotate the rocket so it can go directly in the same point. Why? Because the computers could not do the roll command, flat out. That's how old it was. And then they updated, okay, now the rocket can launch from anywhere, and then rotate and go where it's supposed to go. It was like, seriously? So you have to understand this. Everybody is understanding, yeah, this is showing it. Even Russia is planning to create something else. And nowadays we want reusable rocket. Now this video is shot, basically it is shot on 22. So by the time this video is uploaded, there is a very good chance this rocket would have finally carried human to basically ISS from American soil. Hopefully safely, everything went well. And if it was all going accordingly, I'll cover this in next Monday's video, hopefully. So this was my presentation on a very old workhorse of a rocket. I hope you liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I'd urge you to press dislike, press it twice to show me your disappointment, and please leave a comment because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.